Hello, good evening, students. Today we are going to discussing about the number system in a computer architecture. So basically, four types of number system we learned in the computer architecture. The first one is an binary numbers. Okay, first one is an binary number, and second one is an hexadecimal number. Okay, decimal number and octal number. Totally four types of number system we are going to learning in a computer architecture. So still we are taking if binary numbers means there will be base should be a 2 and the 0 and 1 are the two numbers we are going to using in binary. So by meaning is 2. Okay. How we are going to writing this base in a binary number like this. So take an example of 101. So this is an binary number. Base should be 2 like this. This we are going to calling as a base or radix. Okay. So take this one as a this we are going to writing. We are having only two numbers in the binary. Okay, we are going to calling this one as a core language for an hardware. So what are the hardware parts we are going to using in a computer? For example, take as a transistors and logic gates. These two are the main two parts of the computer hardware parts. Okay. For example, if you want to see how these logical gates and transistors are looking like, let me take one example for this. I will take you guys to logical gates. So we already saw the logical gates picture. I'll show the gate. Okay, these all are the gates we are going to calling. Look at here. This is the gate. So what we are going to seeing here, this is an gate. Okay, look at here. These all are the gates. So this is going to having some numbers. Look at here HD74LS and 3126. Based on okay, so based on these numbers, we are going to indicating that is it's an AND gate, NAND gate, OR gate, or NOT gate, XOR gate. So for different gates, we are going to having a different types of numbers. Okay. For these hardware parts are designed based on the binary values only. Okay, next we are going to taking an hexadecimal. So hexadecimal, while going before the hexadecimal, first we will take the decimal numbers. So decimal numbers starts from 0 and end with 9. Total 10 numbers are there in a decimal. So this we are going to calling decimal numbers human readable input output. Whatever the numbers we are going to using, those numbers are in between the 0 and 9. From 0 to 9 only we are going to using a numbers. So from these 0, 1, 2, 3, 4, 5, from this only we are going to making a numbers again and again. For example, take 11. By using 1 we are going to making it 11. If you want to make a 948, these all numbers comes under a 0 to 9 range only. Okay, 9, 4, 8. By using these 0 to 9 numbers only, we are making the all decimal numbers. Next, challenging requires the conversion of binary processing with algorithm like double, okay, double. So these are kind of algorithms we are going to using these decimal numbers to understand the human readable input output. So let's take an example for the octal also. Octal number starts from 0 and end with 7. Total 8 numbers are there in octal. So we are going to using the octal number simplified binary value we are going to calling this. One octal digit is at 3 bits. So now largely replaced by hexa. Okay, if a 4-bit means we are going to calling that one as a hexa. I will show the table for that. So we are going to writing the octal numbers as a 17 and this base should be 8. For a decimal numbers, take the example for the decimal numbers. I'll write here decimal numbers 91, base should be 10. So this is one example 91 and base should be 10. So this is an example for the decimal number and this is an example for the octal number. So because based on the base, we are going to indicating this is an octal number and this is an decimal number. Take the chart for this complete 4-bit table is there. Look at here how we are going to writing in decimal numbers, binary numbers. Related to that binary number, we are going to writing in hexadecimal numbers also and 8421 also. Let me check the values for this. So for example, we will take from 0 to 7. So 0 to 7, here look at all the This we are going to calling as an bit, 1 bit, 2 bit, 3 bit, 4 bit. Any one digit, 0 or 1, we are going to calling as an bit. Okay. Any one bit, 0 or it may be a 0, it may be a 1. For example, take here. So how many bits are there total? Four zeros are there. So total 4 bits. Okay. For octal representation, we need octal number starts from 0 and end with 7. So we need how many bits? Only 3 bits are enough for us. Look at here. This is an 7 value 3.1. Only 3 bits are enough. All are 0. This fourth bit. So this last bit is not necessary for us. 0, 0, 0. Okay. For the decimal numbers, we need an 4 bit. Look at here. Decimal number starts from 0 and end with 9. So for that, we need an up to fourth bit also necessary for the decimal number. For the hexadecimal also starts from 0 and with 9 and A to F. Okay, I need to tell about the decimal numbers. I'm not explain. Let me check the what are the decimal numbers are there. So decimal number starts with an 0 to 9 and A to F. For example, if you want to write a 10, we are going to writing as a and next for the 11, look at here table. So look at now here for the 15, what we are writing in the decimal, that is an F. Okay. For 14, we are going to writing as an E. So for 13, we are going to writing D, C, B, A. Up to 9, we are going to writing same in the hexadecimal 1, 2, 3, 4, 5. After the 9, we are going to writing 10 value as A and 11 value as a B. Okay. Up to 15, total 16 numbers are there in hexa. Okay. The base should be, we are going to write it. We can write the decimal number example. Sorry, A base 16. So this base is going to indicating A is an hexadecimal number. So I can write 98 base 16. This base is going to indicating this number is an hexadecimal. Okay, this is one of the examples. I think you guys got the clarification of all kinds of numbers. So we already discussed all kinds of numbers. Once we go through these all things, okay, four types of numbers we discussed. Okay, we'll talk about the binary number conversions. So from the binary number conversion, okay, for binary number conversion, get the binary number is going to having only two number, that is a 0 and 1. We already discussed the types of number. Well, while learning about the types of numbers, discussed binary numbers are the two. Okay, that is an 0 or 1. Base of the binary number is 2. We are taking example for the binary number. The sum of the position values and powers of 2's where the bits are 1. Okay. So take for example for the binary number. Okay. This 1, 0, okay, 1, 1, 0, 1. This base should be 2. This is the example we took here. So we are going to converting this binary number in decimal. So that is decimal number base 10. Decimal is 10. So base should be 10. Look at here number. So 1101. We are going to calculating this 11012 to decimal. We will start with to convert this decimal binary number to decimal. You need to take the powers of this. So this is an 2's power, 2 power 0, 2 power 1. This number same 2 power 2. And for this is an 2 power 3. So we already know the powers of 2's. If you want means I'll write here. So 2 power 0. Any power 0 is an 1 in maths. Okay. Any power 1 is that number only. 2 power 2 is 4. How 2 power 2 is 4? 2 into 2 is equal to 4. We need to multiply. We need to multiply 2 into 2 times. That is the value is 4. Okay. So next we will take a 2 power 3. We need to multiply 2 into 3 times. Okay. Multiply 2 2 is a 4, 4 2 is a 8. So 2 power 3 is equal to 8. Okay. Okay. We'll take our values. So already I written all the values. Okay. I'll write this number in the whiteboard. So what is the number here? 1 1 0 1 base 2. We need to convert this one in decimal. Okay. Okay, I'll already written here. So this is an 2 power 0, this is an 2 power 1, 2 power 2, 2 power 3. Just remember for the conversion, 2's power up to 10. So I written here up to 2 power 3, up to here 2 power 3 is enough for us to calculate. So I'll write from here. So from this side, this bit we are going to calling as a MSB. So this right side bit we are going to calling as an LSB. Most significant bit and least significant bit. Okay. Least significant bit, and this is an most significant bit. Okay. This is an most significant bit. Most significant bit. So this is a least significant bit. Okay. So this is an LSB. So which is the having power is an 0. That is the 2's power started from 0. So this is an least value, least significant bit. 2 power 3 means most. That is an higher value. The power should be 3 means most significant. Usually LHS side we are going to calling MSB, and RHS side we are going to calling as a LSB. So we will start with this calculation. So 2 power 3 into 1 is there here down. Look at here. 2 power 3 into 1 plus next for 2 power 2 down is 1 again. 2 power 2 into 1 plus 2 power 1 into 0 is there. 2 power 1 plus 0 value is there. Okay. 2 power 0 into 1 is there. Okay. I'll rub this one. Value is question given is. Okay, look at the question here. So that is the 1101. Base is 2. So we will try to calculate this one. 2 power 3 is 8. 8 into 1 plus 2 power 2 is 4. 4 into 1 plus 2 power 1 is 2 into 0. Okay. No need to calculate this 0 term. So first we'll try to write all the terms properly. Okay. This is an 2 power 0, 2 power 1, 2 power 2, 2 power 3. No need to calculate for this 2 power 0. So 0 value is there means you can directly ignore. So calculate. Okay. Can ignore this 0 term. So look at here. Plus 2 power 0 is 1. Write here 1 into 1. So 8 into 1 is 8 plus 4 into 1 is 4 plus, okay, 2 into 0. Any number with 0 is 0 only, plus 2 power 0, 1 into 1 is 1. So 8 plus 4 plus 1 is, sorry, down here 13. 13 is the value for this binary. So right here 13. Okay. So look at here. What we got the answer for this is 13. So same thing here it is there. So here we got a value as an 13 base 10. So we converted this one with n power and write here as a 13 base 10. This is our answer for the conversion. Just remember the 2's power Okay, write the 2's power starting from the RHS side and end with an LHS side. Okay, start from the RHS side for the powers and end with the LHS side, that is then right, leftmost. So next we will start with an binary to octal. This is a very easiest part. So convert the binary to octal number. We are going to making in three groups. Let's look at this example what they given. Okay. So 1 0 double 1 0 1 1. Okay. For this we are going to taking as a base 2. So look at here. We will make the group from the RHS side to LHS side. Okay. We'll start from grouping from RHS side to LHS side. Make the three groups for the 8 octal numbers because we need an 0, 1, 1 value is 3. 0, 1, 1 is an 3 again. So look at here 0, 0, 1 is an 1. Octal conversion of the binary value 1, 0, double 1, 0, double 1, base 2, 1, 3, 3. We got here the same thing is there here 1, 3, 3. 8. So how I return these values? Look at this chart. Binary values, whatever we took from here. Look at the binary value for the 3. Okay, that is a 0, 1, 1. So binary value for 1 is 0, 0, 1. Same I return there for the octal conversion. Directly you can see and write the values for the octal and you can convert the convert easily from binary to. So binary to hexadecimal, just same as octal only. Need to make here from four groups from the RHS side to LHS side, same thing. Double zero, double one, zero one, zero, double one, zero. The base should be two. Make a four group from the right side to left side. So four group. This was one group. This is one group. Okay. So total 8 numbers are there. So we did two groups here. So this is one group and this is one group. So 0, 1, 1, 0. Get here in the table 0, 1, 1, 0. Where is the value for 0, 1, 1, 0? 0, 0, 1, 1, 0. Okay. The value for 0, 1, 1, 0 is 6. So write down here 6. So for this is 6. So double 1, 0, 1. Okay. So for the double 1, 0, 1, include the table again, same thing here. So for the double 1, 0, 1. So take the value same and take here 13 value and you can write here this is an 13. So in the hexadecimal, we're not writing 13 as a directly. So for that we are going to taking this one as a 13 value we are going to writing as a D. Okay, look at this as an D we are going to write it because in the hexadecimal number starts from 0 to 9 and A to F. So we are taking 10 as a A and 11 as an B. So 12 as an C. Same thing 13 as an G and 14 as an E. Okay, 15 as an F. Okay, so for the 13, what is the value? So here D is there. So I'm writing this one as an G. So I'll drop this one. So now we got the hexadecimal conversion for this one is an D6 base should be of 16. So we converted binary to hexa. So in the hexa, we are going to take 4 bits. Okay, remember this one for the four bits grouping we are going to doing here. So for the octal, for the octal, we are going to making a three groups. Okay, three bits group we are going to making. You just remember this one for making the conversion from binary number to all conversion. Okay, for decimal, it's a very easy thing. For a decimal, we are going to taking in 2's power there. So all you need to take the 2's power here. So you need to start from RHS side to LHS side. Just remember 2's power from 2 power 0 to at least 2 power 10. Just remember the basic powers for the power 0 to 2 power 10. Okay, we'll start with a second conversion. So we'll take a decimal to all conversion we'll discuss. So take an example for the same thing here. We already learned about how many decimal numbers are there. Okay. How many binary numbers are there. So we'll take with an example, same thing here. So here we are going to taking a decimal number. So what are the decimal numbers? You can take any 5 to 3 numbers and here I took an example that is a 45 decimal number base is and 10. So we need to convert this one in binary. Okay, so to convert the decimal number that is a 10 to for base 2. So we need to multiply with that. So sorry, we need to divide that number with 2. I'll divide here. Let me check this value. Okay, take here that write the 45 base 10. Convert this one in the base 2. Let's take a 45. We need to divide the 45 to convert decimal to binary. We need to divide with that 2. Okay, 2 2s are 4. Again, 2 2s are 4. 1 is left. Write this quotient here. Okay, reminder, write this side. So again, divide it. 2 ones are 2 ones are. Whatever the reminders are there, write it. Nothing is reminded, write it here 0. Okay, 2 5s are 10. Write the reminder as a 1. 2 2s are 4 and reminder is an 1 again. 2 ones are 2 and nothing is reminded, write it here 0. So make the group from down to up. Okay, I'll write here all the digits 1 0 1 1 0 1. So this is the binary value for the decimal number 45. So if you don't know how to take the LCM for the two, exactly you start dividing it by two. So make the twos group. If you have a 45 rupees, okay, make the off of 45 rupees, you may get the 22. Okay, one is reminder, take it one is here. Exactly you need to divide. If point 0.5 you are getting like that means write it reminder as a 1. Okay, here in the reminder section you are getting only 1 zeros values. Okay, so for 22, so make the half of 22 is 11. So half of 11 is 5, 5, 1 is reminder. For 5 off is and for 2 to 4, again write it as a 1. So write it as it is here. So this is the answer pause. Let me check here. So what is the answer we got here? Starting from this side down to up, we are writing. That is an last bit we are going to calling MSB and LSB. I'll write here 1000. This comes here left side. Okay. LHS part, the last digit of the LHS part, we are going to calling this one as an MSB, most significant bit. This one as a least significant bit. Okay. So take one more example. I'll give two examples for the again for doing yourself with yourself for that. Next, we'll convert the same decimal value. Okay, take the decimal value 95. We'll convert this one in octal. To convert the decimal value octal, you need to divide. Two methods are there. First, convert this 95. Okay, 95 to first method. I'll tell by taking exactly divide with 8 again. Okay, divide with 95 with 8. First method, this one. Okay, 8 ones are take 8 ones are 8. 15 is there. You can't again divide 15. So I am taking 8, 8 ones are. Okay, take it as a again 8 ones are 8. So how much is left here? So in the 15, if we are taking only 8 means here 7 is left. Write it as 7 here as it is. Again 8 ones are. How much is left here? 8 ones are 8 means 3 is left here. So what is the value we got here? 1, 3, 7. So these all are the remainder. Again we can't divide. Again we can't divide this one. Okay, I'm writing here. This is from decimal to octal. Write it as a base 8. This is the one method. How we did for the decimal to binary. There also same thing we did, but we are there we started dividing with an 2 here. Okay, we started dividing with an 2. We divided all the decimal number by 2. Remainder we written as an answer. Same thing here, we need to divide with an 8. We need to write the remainder as an answer. Otherwise, if it is too difficult to divide with 8, don't get confusion. For this, take a 2, 2 4 is 8. Okay, same thing you need to do here. I'll take this from this side. Take 95. So divide with n 2. Again, same thing. Convert this one in a binary. First, so 4 is 8. I think it's very easy for you guys. 2, 2 7 is 14. 1 is left here. Okay, same thing. 2 2 is 4. And next 2 3 is 6. 1 is left. 2 1 is 2 1 is okay. Again 1 is left. 2 5 is 10. 1 is left. 2 2 is 4. 1 is left here again. So take one more 2. 2 1 is nothing is left. Make a group from here to here. The value is 1 0 triple 1 or double 1 again. This is a binary conversion of the decimal number 95. Same thing. You need to make a 3 3 group from the RHS side to LHS side. This is an one group. Okay. Again, this is an one group. One is left here. Take two zeros. This is an again one more group. So triple one means in the triple one value is get here. Triple one are there. Value for this triple one is so for this one. So 137. We got the same answer. Two methods. Okay. Same answer you are getting by using the two methods also. Okay, next we'll start with a decimal to hexadecimal conversion.